Hello everyone, welcome to this YouTube channel New Life Academy. Here we orientate, we inspire and prepare students for an all-round success journey. We help you redefine your priorities and stick to what works.
The first question says that show that for every real value of x not equal to 3, x squared plus 2x minus 11 cannot take any value between 4 and 12. So we start by letting p be equal to x squared plus 2x minus 11 on x minus 3 into x minus 3, cross multiply to give you x squared plus 2x minus 11 px minus 3p equals to x squared plus 2x minus 11. So x squared plus 2x minus px minus 11 plus 3p is equal to 0. So x squared plus x into 2 minus p plus 3p minus 11 is equal to 0. So from here we see that a has a coefficient, x squared has a coefficient of 1, so a is equal to 1. X has a coefficient of 2 minus p, so b is equal to 2 minus p. And c is 3p minus 11. That's the coefficient of x to the power 0. In our question, let's say for every real value of x, and we know that for every real value of x, b squared minus 4ac is greater than or equal to 0 for every real value of x. So this is a principle that we're going to use to prove that for every real value of x, x cannot take any value between 4 and 12. So let's substitute b here, a and c. So we're going to have 2 minus p all squared minus 4 into 1 into 3p minus 11 is greater than or equal to 0. 4 minus 4p plus p squared minus 12p plus 44 is greater than or equal to 0. I'm simplifying this. So I'm going to get p squared minus 16p plus 48 is greater than or equal to 0. We're going to solve this by the method of factorization because this is a quadratic. Yeah, so can use the method of factorization or the method of completing the squares or the formula method. I have a video on my channel teaching us how to solve quadratic equations using any of these methods. So you can do well to watch that video. So solving this by factorization will give us p minus 4 into p minus 12 greater than or equal to 0. Now if we get the solution of this equation, we're going to have two boundary values or two values of p. That's 4 and 12. And so 4 and 12 are going to be our boundary values as we check for the range where that expression is true. Values are 4 and 12. Our possible ranges are P less than or equal to 4, P line between 4 and 12, and p greater than or equal to 12. Those are the possible ranges that we can have with those two boundary values. So right now we'll draw the table where we'll verify the range that satisfies our equation. P less than or equal to 4, 4 less than p less than 12, and p greater than or equal to 12. Our first solution is p minus 4. Our second solution is p minus 12. That will give us p minus 4 into p minus 12. So to verify that, we'll pick any value in this range, p less than or equal to 4. So we'll pick any value less than 4. For example, 3. Now we'll substitute 3 in this equation. 3 minus 4 will give us negative 1. So it's a negative value. No matter the number that we pick in this range, it will give us a negative value in this equation. Now in this equation, no matter the value that we pick, no matter the number we pick in this range, substituting it in this equation p minus 12 will give us still a negative value. Because here we pick 3. 3 minus 4 give us a negative value. 3 minus 12 will still give us a negative value. And multiplying the 2, because here we have p into 4, p minus 4 into p minus 12. So multiplying these two solutions will give us what? A positive value. Now if we pick any value in this range between 4 and 12, for example 5. 5 lies between 4 and 12. So placing it in this equation, 5 minus 4 will give us 1, which is a positive number. In this second equation, 5 minus 12 will give us negative 7. It's a negative number. And multiplying the 2 give us a negative solution. Now here in this range, we pick any value greater than 12, greater than or equal to 12. So let's pick 13, for example. 13 minus 4 gives us 9. It's positive. Now 13 minus 12 gives us 1. It's positive. So here, the solution can only be positive. Now we have verified to see the sign of the solutions in each of these ranges. You see that for p less than or equal to 4, it is positive. Positive means that it's greater than 0. Between 4 and 12, it's negative, meaning that it's less than 0. Between greater than 12, it's positive, meaning it's greater than 0. So let's check which of these ranges satisfy our equation. After solving, we have something like this. P minus 4 into p minus 12 greater than or equal to 0. So this is the inequality we're working with. So the set of solutions that satisfy this equation and consequentially this equation is the range where we have the result greater than 0. Greater than 0. So we'll have a positive solution, and that is here and here. So after drawing this table, we will conclude that from our table, the range that satisfies our inequality is the range p less than 4 and the range p greater than 12. So this is how we write it. After drawing the table, we realize that the set of values or the range that satisfies our inequality is the range p less than 4 and the range p greater than or equal to 12. P less than or equal to 4 or p greater than or equal to 12. And the range of values that lie between 4 and 12 don't satisfy our equation. So this is a proof to tell us that this expression x squared plus 2x minus 11 on x minus 3 cannot take any value between 4 and 12, because this is the range that lies between 4 and 12. But you see, it has a negative solution less than 0, and so it does not satisfy our inequality. Our inequality is p minus 4 into p minus 12 greater than or equal to 0. So a positive range. This negative range does not satisfy this inequality. So this is the proof. This is the proof to show that this and consequently this cannot take any value between 4 and 12.